Stuck inside because of a rainy day? We're giving you an experiment that can help counteract your boredom. Hi everybody, we are Engineering Ambassadors. My name is Charlie, and today we're going to be bringing you another fun experiment that you could do at home. Today, what we'll be doing is building bridges. If you're ever outside and you look around, all you see is buildings, roads, bridges, a whole bunch of landmarks. All of that was designed by civil engineers. Civil engineers are important for designing, constructing, and maintaining anything physically built that you see all around you. It's different from mechanical engineering because with mechanical engineering, you're building more of, mechanical systems. In civil engineering, though, you're building more structures, stuff that is a little bit more stagnant. Well, not necessarily stagnant. Here's a fun fact for you. Did you know that skyscrapers actually move and sway from side to side? That's because of the wind acting on the building. It could actually make the building move a few feet. It's a cool idea and all, but civil engineers try to keep structures' velocity as close to zero as possible and keep it that way. If all our buildings move too much, they just tip over and fall. That's why civil engineers use mathematics to make sure that nothing bad happens to our structures. Today, we're going to focus on one part of civil engineering, and that's building bridges. Some bridges are simple, and they could be used as a walkway to cross over a small river. Others can span miles long and have to carry hundreds of thousands of pounds. Either way, they have to be built in a way to carry a certain load, and they can't break under all the weight. There are many different types of bridges, and I'll be going over a few to see how well they withstand a certain weight. Let's start now. You're going to need a few things for this experiment. First, you're going to need two objects of similar height, some glue, some scotch tape, some pipe cleaners, and some popsicle sticks. If you need more time, all of the materials can be found in the description below. First, you want to tape down these two objects to make sure that they don't move. I'm going to give myself 8 inches of space to work with. Now that that's done, I'm going to start making the bridges. I have a few designs in mind, so I'm going to start putting that into play. But I will have to keep in mind that these popsicles are not long enough to reach the other side. Well, you kind of have to work around that. So, we'll see how it goes. Alright, so I finished making bridge number 1. Doesn't look the prettiest, but hopefully it'll do its job. Alright, so now it's time for the strength test. I have two objects of varying weight, one heavier than the other. I have a Rubik's Cube, pretty light, and filled up soda can, and let's just hope it doesn't break. Okay, this is attempt number 1 with the Rubik's Cube. Let's try it out. Ooh, okay. It didn't break on that one. Let me try changing position. Still fine. Putting it right in the middle. Still good. Didn't break. So, I guess now it's time to try the soda can. I don't know about this one though. This one's pretty heavy. Wow, it actually didn't break. Okay. That's really good. I also made another bridge out of popsicles. I wanted to test this one out. This one is a little bit more sturdy than the last one, but the last one didn't even break, so I think this one will be good too. So, attempt number 1 with the Rubik's Cube. Completely fine. Put it anywhere. Won't break. Nice. And let's try the soda can. I'm not even worried at all. It seems completely fine. If I put it over here, it might tip over. See, this isn't touching here, so, but at least it's sturdy. So, luckily, both bridges were a success. Neither of them broke, and everything went well. The most important thing about civil engineering, though, is you're going to have a budget when trying to build something. So you want to use the least costly material there is. I'm still going to build the other bridges right now because I might get one that's just as good, but using cheaper materials. This time I'm going to build it straight onto these two objects, so let's start. So it's actually funny, right there I just ran out of tape and well, I only have these two pieces of tape right here. So I guess we could see if it works. Let's test out this Rubik's Cube. Okay, well the Rubik's Cube holds. Once again, it's pretty light, but I don't know about the soda can. I think the soda can will most likely break it. Let's see. Oh, it's standing. It can't really balance though. It doesn't have much room. Yeah, it keeps tipping over. But it did hold. If I let go of it for a second, maybe if I put it on its side. Ooh, it held perfectly. I probably won't even need to try the pipe cleaners, but I guess I could give it a shot. Even just 2 pieces of tape is able to hold it down. That's amazing. I did not expect that to happen. So as you just saw there, the 2 pieces of tape was even able to hold it up, and that mimics more of like a suspension bridge. I guess now I could try the pipe cleaners. I'm pretty sure that it's gonna work, but I might as well give it a shot. So once again, I'm gonna build this straight onto the 2 objects, and I guess we can start now. Okay, I finished making the bridge, and now it's time to test it out. First test, Rubik's Cube. Holding up well, stand perfectly, that's fine. Even put it on other parts of the bridge. That's good. Now for the soda can. That leans a lot. Oh, but it still is staying up. I mean, actually, to be honest, it's kind of just like standing, like on the ground, but just over the pipe cleaners. It seems to be like not tight enough. Maybe I could try moving it back more. I can't really because of the tape holding it, but I don't know what you would call that. I don't know if you'd say that's a fail or a success, because that would most likely be, if this was over water, it would most likely be in the water by now. So, call it what you will. So, as you saw, that one was able to hold up the can, but you could debate on whether it really actually counted. You see, that's the cool thing about civil engineers. They don't say like, oh, it might have worked, slightly worked, it might not have worked. They make sure it works. They use all their calculations to make sure that nothing goes wrong. When you're a civil engineer, you have to plan for every little thing that might happen. And that's why they're able to build all these amazing structures that you see around you. If you're interested in learning more about this kind of stuff, I suggest you guys look into it, and maybe you guys can become a civil engineer. I had a fun time doing this experiment, and I'm not even a civil engineer. Whatever it is you may choose, just make sure you have a fun time doing it. I hope you guys enjoyed watching this video, and I'll see you in the next one. Bye!